Hi, I'm Rares. I work on the NX Cloud team, and for the next 20 minutes, I'd like to talk to you about this single line of code. But we'll get to that in a bit. So, CI systems, like Circle, Jenkins, GitHub Actions, they're really good because they constantly test your code to make sure nothing broken gets onto the main branch. But they can also be incredibly frustrating when they become slow because your productive flow keeps getting interrupted while you wait to see if your code has passed all the checks. For example, let's say you're working on a branch. So you open up a PR and your CI starts running, and because it's so slow, it takes 40-45 minutes, you move on to doing something else. So you might move on to a different branch, you might go for coffee, I don't know. But then your CI fails. So you go to see what happened. So it's like, oh, it's that flaky end-to-end test again. So you decide to fix it once and for all. You fix it, you merge your changes onto main, and you rerun your CI on your original branch. And of course, it takes, again, 40-45 minutes to rerun the checks, so you might do something else. This can become tedious very, very quick. And I can assure you, most of your team is going through kind of the same experience. Having a slow CI really reduces your team's velocity and the speed at which you can release new features to your customers. It reduces collaboration, but can increase frustration. Today, we're announcing a new way of running CI with a bit of a shift in how you think about your task pipelines. We're calling it NX Agents, and it's actually been a while since I was so excited to talk about something. In the earlier days of programming, when most features were written in C or Fortran, you had to constantly keep in mind lower-level programming concepts, such as memory management. You had to keep track of what data you put in what parts of your memory. And if you forgot to clear it, you would get memory leaks, you would get buffer overflows, all these weird bugs. When languages like Lisp and then later on Java came along, they suddenly had this concept of garbage collectors. These smart algorithms constantly watched objects you created in memory, and if they found those objects were not being referenced anymore, they would just clear up the memory for you. We did not have to worry anymore or think about our underlying machine. If I wanted to put an item in a list, I could just do it without having to worry whether I've allocated enough space for that list initially. Because of these smart automated runtimes, instead of writing code for a machine, we could instead focus on readability, on writing code for other humans and telling them the story of our business logic. And there's a similar feeling about our CIs nowadays. We have a bunch of tasks we want to run. And because they're all running on the same machine, this will get slow eventually. So we create all these parallel jobs and virtual machines, and we just start assigning different tasks onto each one of those jobs. While it's a bit more complex in real life, it's usually some variation of this. So you might have maybe some builds on one of your jobs, some other builds, slow builds on another job. You might have a GitHub Actions job for tests, a GitHub Actions job for running your lint tasks, or anything else. And this is how that might look like. So you have some jobs, and each one of these represents a separate virtual machine. And we would put some tasks on one machine, and each one of them would have to check out the repo, set up Node, install dependencies, and then run our tasks. But some of these problems come in when you have something like this. So now that I want to upload my test results to SonarQube, I need to make sure I run this task on the same machine where my tests also run, and any other machine where I also have tests running. Or something like this, where you have end-to-end tests to run, but these end-to-end tests depend on the builds of the apps or libraries they are testing. So we need to make sure we run both of these on the same machine. And if any of these fail, or if we want to look at the logs, well, we're going to have about 5 or 6 different log streams that we need to look at depending on how many machines we've created. All of this is a very machine-oriented config. We need to always think about what's running where, are all the tasks perfectly balanced, is one agent taking more to run than other agents, and it's going to get especially complex and hard to manage for monorepos, because monorepos tend to scale very quickly, and they have a lot of complex dependencies between tasks within them. But what if we didn't have to think about distribution at all? What if we had something like those modern programming language runtimes that could figure out distribution for us? And I couldn't wait to get here because this is where I get to talk about NX agents. If we didn't have to think about distribution, then we'd put all of our tasks on this single GitHub Actions job, telling a story step by step of what needs to happen on each one of our CI runs. And of course, this might get slow as you'd expect. So let's say this would take even maybe 30 minutes to run all of our affected build, tests, and lints. But if I run this single command, and I hinted at it a bit earlier, but I will ask NX Cloud, instead of running on a single machine, to distribute all my tasks on 6 medium agents. Now, if I just add that single line, instead of this running in 30 minutes, it might now complete in 3 to 5 minutes because it's getting distributed. But how does this work? Let's take a look. So now when my CI starts running, it will just check out the repo, install Node, and when it gets to the distribution line, it will just make a quick HTTP call up to NX Cloud, and then it's going to continue installing dependencies. In the meantime, NX Cloud will spin up all these agents here in the background. And this is what NX Agents is. It's compute power managed by us running on our secure clusters. For the first time ever, NX Cloud can spin up CI agents for you. And turns out we can do some pretty cool things now that we can do that. And by the way, NX Agents is an addition to NX Cloud. It's part of the NX Cloud offering, just to be clear. So these agents will do their own setup steps now. So they might check out our repo, will do the npm install, just to get ready for what's coming. And then when our main job gets to this line here, and by the way, NX Affected is a collection actually of all these tiny tasks that represent what's been affected by our code change in a pull request. Instead of running them, NX will instead ask NX Cloud to run them for us. And they will just start getting distributed among all these NX Cloud machines. Because all of these agents will have the same copy of your repo, the same node modules installed, they can get to work running all those tiny affected tasks that NX Cloud told them to run. And our main task? It will just wait there in the meantime. Remember, there's a live connection between it and NX Cloud. So as tasks finish, outputs our agents produce will start getting replayed back on our main GitHub Actions job. And I'll show you a demo of this in a bit. But when the agents are done running, we'll just pin them down. And GitHub Actions will continue running the next steps. And because all the build results have been replayed onto the main agent and all the test results are also on there, we can deploy a PR preview of our app using the build outputs of the previous task. We can also upload our test results to SonarQube. If I want to make it a bit faster, I could just increase the number of agents I want here. If I need more powerful machines, again, I can specify a different launch template. And just to be clear, NX Agents does just the distribution part for you, but you can still use your main CI to define your workflows and your tasks. So for example, this is how your Azure configuration might look like. Again, you have your tasks defined on there, and then you start the distribution command up here. This is how the Circle CI config will look like. This is how GitLab will look like. This is how Bitbucket will look like. So you can use anything you want, even Jenkins. But what are these? Well, we call them launch templates. And let me show you a demo of them. So we have this public GitHub repo over here. And here we've defined what we call some launch templates for you. So there are some instructions on how each different agents can be spun up. So for example, the medium ones, they use a medium resource class. So this defines what kind of resources gets assigned to your machine, like CPUs or memory, what kind of base image these agents should run on. So again, we'll have a few of these provided for you. So this will run on Ubuntu using some version of Node pre-installed, maybe some browsers for testing for running Cypress or Playwright. And then they'll have some initialized steps. So they might all check out the repo, restore a node modules cache if there is any, install node modules if there's no cache there. So the goal for this is to try and have a few very common steps that will work for most use cases. And we want to work with you on this. So if you are going to have any custom use cases that you'll need, we want to have as many of these ready for you as possible so that you don't have to declare your own and you can just use one of our predefined ones. But let's see this in action right now. So let me quickly switch to my terminal and I will just push some changes that I've made. And I'll go back here. And if I go back to my pull request, I first want to show you this CI run that I did where I didn't have any distribution at all. So all it's doing is it's running my affected build, lint, and test. In this case, if I go to my main job, we can see that it took over like around 20 minutes to complete. And most of that time was spent running my affected tasks. So it took around 19 minutes to run that. If I go back to my pull request and I look at one where I enable distribution, so the only change I made here is that I added this line where I asked it to distribute on my agents. If I now go to the checks, this finished in 5 minutes. It's the same exact CI config, but with that line included. And if I open it, again, it reduced my tasks from 19 minutes to just 4 minutes. And of course, the effect will be even greater the longer your initial CI times are. And now if I go back to my pull request list, I'll see that there's this in progress PR happening. And on my NX Cloud web app, if I refresh the page, I can see there's an in progress CI execution. And we'll see here how long ago it started and the hash of the commit, maybe the branch where I started. I can click on here to go back to GitHub and see the exact commit that it's running. I can see who made the commit, how long ago. And down here, I'll see all of my agents. I can see that it's using my Linux Medium.js launch template that I showed you earlier. And these are all the steps that our agents are running, checking out the repo, restoring the node modules cache, and you can see all the different agents on here and how long it took them from the fastest to the slowest to complete that specific step. And I can see most of them are now running my NX tasks. And I'll go up here to this nice graph, and this represents how many tasks I queued up. So 400, like it's a lot. And how many have completed, maybe 72. How many tasks are still in the queue, and what tasks each agent is currently running, and which ones have been completed, and on which agent, and how long they took. So it's pretty cool. But if I scroll down, let's select one of them. So let's go to agent 2 that's currently running this build. It's going to take me directly to the logs where I can follow what this agent is doing right now. And I can click on different agents up here. So I can click on this one and see the logs for this one. So eventually it might run different tasks. Maybe this one, it's doing something else. Yep, so it keeps executing things. But the interesting part is, if I go back to GitHub now, and I go onto my main job, I'll see all these logs from all of my agents being streamed in real time back to my main GitHub Actions job. So we're using NX Cloud to replay all the terminal outputs on here. And that's why things like the JavaScript bundles or the test results will be available here. But there's one more thing I want to show you before I close this. If I go to the top again to my pull request, and there's this PR here, and there's a neat comment on here that I can click on, and it's going to take me directly to the page for that CI execution. And on here, I can see that it completed successfully, but some agents failed on the npm install step. And that could be possible maybe to network issues, or maybe npm had some issues at the time. I don't know. It is possible that sometimes some tasks might fail on your agents. But in this case, it still completed successfully because the remaining agents could pick up the remaining NX tasks. Of course, sometimes you might want to run your own steps. So maybe our launch templates are not enough and you want to run some unique step. So we got you covered in that case as well. You can define in your .nx/workflows folder, we'll define this agents.yaml file, which looks similar to the launch templates which I showed you. So we can give it a name. I'll call it, you can define a bunch of these in here, but this one I gave it the name of custom Linux medium. Again, you can define your resource class depending on how many resources you'd like to be assigned to that machine. You can define a custom base image. Again, we'll provide a few base images for you. And this one will check out the repo. It will restore the node modules cache if there's any. These are some predefined step templates that we created for you. And down here, for example, we are installing Rust. So I have a custom bash script where I'm installing Rust because my NX tasks will need Rust to be installed. So this is my custom defined agent. And now if I go back to my GitHub Actions definition, I can just use my own launch template in here. And by the way, I've always used this as a demo command, but you can also run as many NX tasks as you want on here. This is the interesting part about this. Once you add this line, any NX command that comes after it will get distributed instead among the agents that you made available to it. So NX will take care of the distribution for you. So why would we even go into managing compute? Because it's a pretty big jump if you think about it for a company as small as ours to make. But it turns out it's an extremely great fit given all the tools we've been building over the past few years. As an example, as all these tiny tasks get allocated to my agents, when you have a tool such as NX that knows about your dependency graph and how projects depend on one another, we can make sure we distribute the tasks in the correct order, such that those blue end-to-end tests there always get scheduled after the builds in the bottom agent have completed. We know that those end-to-end tests depend on those builds, so we can make sure to take care of task ordering for you so that you don't have to worry about it. And it turns out having a distributed cache like Nxcloud is great for continuously replaying results from the agents producing build results to other agents that might need those build results, including replaying outputs and terminal outputs back onto the main agent as we have seen. And because we know from historical timings how long each task takes on average, we can try to perfectly fill in these gaps for you such that there's no idle agent time. And as mentioned, because of our distribution model, if one of these agents goes down, we can continue just fine with the CI run, distributing the remaining tasks among the remaining live agents. That's a problem with existing setups, because when you have your GitHub Actions job, for example, if you declare on that job that it's going to run these tests, there's nothing else that can run them. So if npm CI fails, your job will fail, so your whole CI execution will fail as a result. And one big problem with current CI providers is that once you declare your matrix of jobs and agents, it's pretty static. If you customize it for 20 agents, you'll always spin up 20 agents, even if you change just a single test file. You could make it a bit more dynamic. Some CI providers allow you to do that, but it gets really hard to maintain, even more than it already is. With Nxcloud, I can create a new dynamic sizing config file that will look something like this. So now, if I open up a small pull request, I'm just going to spin up 3 agents. If I open a medium one, I'm going to spin up 6. And if I open up a large pull request where most things get affected, I'm going to need to bring in all the agents I have available. And we know this because NX knows about your dependency graph and it knows what tasks have been affected in each PR, so it can calculate in which one of these 3 buckets your pull request might fall in. So that's it. Thanks so much for listening, and please check out the Getting Started docs on NX Agents. Thank you so much. See you next time.